Hi everyone, this is Howard. Welcome to another StarTalk Tuesday. This Tuesday, May 26, 2020. Now this week, of all the things that we can potentially talk about in the sky, I want to focus on one. And this is, for many of us now, this is going to be an early morning object, but there's some interesting things going on. And I'm just going to kind of cut to the chase here. We're going to take a look at Jupiter. Jupiter is one of the most beautiful things to see in the sky. And of course, what we're transitioning into now, of course, is spring to summer skies. So we're starting to see the summer constellations creep out of the eastern sky, rising up in the evening. And the spring constellations now setting into the western sky. And as time goes on, we'll see those summer constellations rising earlier and earlier. Now, as a consequence of this, what we see is this shift from what is a galactic view into a more, or I should say intergalactic view, into a Milky Way view, looking at parts of our own Milky Way galaxy back to the star-filled regions of the Milky Way galaxy. And along with that part of the sky come the planets, those that are the brightest and of course the most visible, Jupiter, Saturn, and Mars. And those are in the early morning hours. So let's go ahead and just accelerate into the evening, of course. And I'm going to try to remember to do this gently, because I know it can go by pretty quickly. So I'm going to adjust our view for the moment to the southwest, where you can see the sun is setting. And right about there. Let's see. Let's bring this in a little bit closer, perhaps a little bit more time. There we go. So here we are. This is 2037 or 837. And as we look towards the west, we look, and I think I turned them off. Yep, there we go. There it is. There's Mercury. Now, I'm going to have to get that tree chopped down because that tree keeps getting in the way. Mercury here, for those of us that are happening to look west, and I really wish that tree wasn't there now, looking to the west, I can't believe this. In real life, trees are a problem. In my digital world, trees are a problem. In any case, if you're looking to the west at this time of the evening, you'll be able to see Mercury. And if memory serves me right, I think Venus was just preceding it, but of course my digital tree is blocking my view. But for many of us, there will likely be real trees blocking the view because you can see where it is relatively low on the horizon. So for keen-eyed observers, if you're paying attention, you'll notice Mercury way down low in the west. Now, up high in the sky at this point, sinking into the west, is the moon. And so let's take a close look at the moon, because the moon right now is in one of its ideal phases for observing. And as we get closer, we see this beautiful crescent phase. I'm going to go ahead and, just for the moment, lock onto the moon. That way it doesn't slide through the sky on me. There we go. There we go. I'm going to go ahead and pause time. Now, the daytime side of the moon over here, of course. Nighttime side over here. We're looking along the terminator. And on this particular day, the terminator falls right here, as you can see. The interesting part of the moon as you observe it is that that terminator continuously falls in a different place, using shadows to reveal the contrast and the textures of the moon. And that's where we see the shadows that reveal mountain ranges and valleys and canyons and holes in walls that cast long stretches of light into otherwise dark craters. It's truly, with an amateur telescope, the moon is one of the most gratifying targets you can look at in the sky, and dynamic in that the shadows reach out and stretch and change, and you can watch over the course of perhaps minutes a crater, say right here. Let's get in a little bit closer. You could watch as the light of the sun creeps over the horizon of the moon and starts to reveal the far, say, eastern wall or western wall of the crater. As light starts to land on it, you can see that happen in the course of an evening as you observe the moon under powerful magnification, and that's why the moon is one of the most fun targets. And right now, this is when I love the moon, when it's not too bright and it's not wrecking everything else. Now, very close by, I think should be able to see it, but well, we should be able to see it digitally. I think if I get it out, yep, there it is. Look at that. That's how smart this program is. Right there is a star cluster in the constellation. This is Cancer, the crab, right here. So if we pull out, now it disappeared, and of course the reason why is Stellarium knows that, well, the moon's in the view, and when the moon's in the view, you're not going to be able to see that, and certainly with the naked eye tonight, you will not be able to see that star cluster that is right there. But if I can make it go away, there it is. So there's this little clump of stars called Precipice, or the Manger, found in Cancer, right below the moon. Okay, now let's work our way into the evening. We're going to change our view back to the south, and now we're going to move into the morning of the 28th. Try to do this pretty quickly. There we go. And there you see satellites zipping across the sky. There comes Scorpius. In fact, we'll add the lines so that everyone can see familiar shapes and patterns. And we want to head to right around 2:30 in the morning. So I'm going to take that to right about there. Ah, that's good. Okay, so now as we zoom in, it'll take us right to Jupiter. Now we can see clearly there's a lot of stars. There's the Milky Way galaxy. There's the central region. Nestled right in between. We'll put the artwork up for a moment. Right there between Scorpius and Sagittarius and Jupiter. It's in a very unglorious position here behind the Centaur here. Anyway, the artwork kind of reveals the sense behind all of those crazy patterns that we see. Let's get rid of the artwork. There's the teapot. If you can't see the Milky Way, the teapot is a visual reminder of where you are in that general vicinity. The teapot on one side and the fishhook of Scorpius on the other, you know that the Milky Way central region is kind of nestled right in between them. Anyway, trailing behind the teapot is Jupiter, and this is our subject at the moment. So I'm going to go ahead and just lock onto this. And now we're going to zoom in. So this is 2:35 in the morning. I know this is really late. But for those of you that are interested, and I don't know, I think this is the time. I'm going to get rid of the labels here for a moment because I think they kind of get in the way. But for those of us that have time right now, this is something you might want to make some time to see. While this is a common event in the context of Jupiter, it's not something that humans commonly see, and that is a shadow transit across the face of Jupiter. So Jupiter has 4 Galilean moons, the moons that were visible to Galileo. We see 4 of them labeled here: Callisto, Io, Ganymede, and Europa. Now those are the 4 moons that you can actually see in a pair of binoculars. They look like faint little stars around Jupiter. Now, of those 4 moons, Io, Ganymede, and Europa, those 3 will be leaving shadows across Jupiter here over the next couple of days as they move between Jupiter and the Sun, and as our Earth turns and rotates onto the nighttime view, happens to coincide with that shadow transit. We're seeing the equivalent of basically a solar eclipse on Jupiter. So let me just stop babbling and let's go ahead and just get to that point. So it's going to happen right around, actually, well, first off, it's Ganymede. And I'm going to zoom in. Now this, let me actually pause it for a moment here. The view that I'm going to show you is so you could see observation of what's happening, but it's not necessarily as good a view as most of us will ever get in a telescope. And I'll reveal what you'll typically see in a telescope versus a pair of binoculars. But I want you to have a little fun here so we can see what's happening. So let's go ahead and move the clock forward a little bit faster, and right around 2:40, we're going to see Ganymede there. In fact, let's turn off those labels. They get in the way. We know what we're talking about now. So there's Ganymede. There it is. You can start to see its shadow starting to appear. And right around 2:40, for those visual observers with telescopes, you'll start to get a sense of it. There it is right there. And we got a really special treat. Because to see one shadow transit across the face of Jupiter is pretty awesome. But here comes Europa. And it gives us two shadows. So from around 2:40 in the morning to around 5:15, you can see the entrance of Ganymede's shadow across the face of Jupiter. Followed at around 10 minutes to 5, Europa's shadow will start to transit. And then right around 5:15, they've moved into a position where you can see both of those shadows at the same time. Now this will, I'm not going to exaggerate, this is going to require a telescope to see. But if you can, let's back this out. You'll notice that the shadows, while they get really, really small, what they represent is an enormous amount of contrast. So you can imagine a tiny but very bright, intense light in a very black area. You can see it even though it's small because of its contrast. In the same way that there's a very brightly lit area and there's an extremely dark area in contrast, you can see that as well. Perhaps not as easily, but in a pair of binoculars, in my 25 by 100s, which means fairly large, you can see the shadow of the moons as they transit across. But as we pull out to about here, and this is about the range. Now those moons are not going to look quite as big as that. They're greatly exaggerated. They're going to look like tiny little stars, but Jupiter will look right about like this. And I know that most of you can't see this, but there is a tiny little black speck there. And with binocular observers, depending on the amount of aperture you're getting, you may be able to see those shadows. Now, the truth be told is that I'm going to believe that most of you that have your average terrestrial binoculars, you'll not be able to see this. But for those of you that have telescopes or have friends that have telescopes, perhaps this is your opportunity to go convince them to go break it out and take a look at Jupiter on the evening of May 27th into the morning of the 28th and see a double shadow transit. Now, this is the morning of the 28th, and I'm going to show you what's going to happen again with Jupiter, except on the next morning. And so I don't want to fast forward through the day. So what I'm going to do is go backward in time just a few hours. Well, I want to take this back to about 3 o'clock. I'm going to take you back in time to take you forward in time. You'll see what I mean. So I take you back to about 3 o'clock. There we go. And now I'm going to move us one day forward in time. There we go. So now it's the morning of the 29th. So another day has gone by. We've had the all day of May 28th into the evening of the 28th, now into the morning of the 29th, and now we're looking again at Jupiter. And yesterday we saw the shadow of Ganymede and Europa. Today we get to see the shadow of Io. So as we watch, this is right around 3 o'clock in the morning, give you enough time to get your coffee into you and get your telescope set up. And as we move the clock ahead, it'll actually be a little bit earlier than this, but I think visually for us, we'll see it right around, perhaps around 10 minutes after 3, perhaps around 3:10, 3:12, something like that. See, now it's already starting to show up. There it is, 3:12, and 3:13. There it is, 3:15, and it's just shown up on the limb. Let's accelerate that to a nice, beautiful moment in time. Right here. Right around 5 o'clock in the morning, folks. This is what I would call the Kodak moment. I'm going to get rid of the labels here. Oops. Just want to get rid of all the labels and just show you what we're looking at. We have Jupiter itself, which is an excellent observational target. We have the ever-elusive Great Red Spot. It's actually going to be visible at this time. That's a feature of Jupiter that people frequently time their observations to see. So here, Stellarium is not deceiving you. At 5:06, you will see the Great Red Spot there. You'll also see Io. Now, this is the interesting part. Io itself is extremely visible when it's against the black sky. But as soon as it crosses the limb of Jupiter, well, it's like a sort of a bright light against a very bright light. And so Io, or any transiting moon for that matter, becomes very difficult to see. It's not that it can't be seen, it's that it requires some optical equipment, usually telescopes, to see the view. If you're looking with a pair of binoculars, Io will just kind of disappear. Maybe if you have some keen eyes, you might notice it. So I don't want to speak for everyone. Everyone's kind of observing conditions can be a little bit different. But with telescopes, you'll be able to see the red spot, and if you pay attention, you'll be able to see Io, but you'll also be able to see that shadow of Io, and you can see where the shadow is in relation to the moon, kind of belies the location of the sun in this context. I'm holding my hand up again in the air because I always talk with my hands, and I realize nobody can see my hands again. But the sun is off to the left, and its light is coming at this particular angle and hitting Io and leaving a shadow way over here. So even though Io is in front of Jupiter relative to our view, the shadow precedes it, and pretty soon the shadow will just whisk itself right off. Whoops! Sorry. Let's lock on to the target. And then we'll add, I said lock on. Oops. Howard doesn't know what he's doing. There we go. I have to lock on like that first. There we go. And there goes Io. Now, this is 6 o'clock in the morning. So as we watch Io move off across the face, for the rest of us, what you'll notice is the sun coming up. So you've run out of time if you want to keep looking at Jupiter. Now, you could continue to look at Jupiter. It is actually visible in the daytime, but I have a feeling that most of us will have some responsibilities to take care of in the daytime. Anyway, with that, folks, thanks again for joining us. That concludes another Star Talk Tuesday. See you all next time.